These pesky negative signs tend to give us issues on our one-step equations. It all seems so easy until you throw the little negative signs in there. So we need to remember that whatever we do to the left, we do to the right. We always want our x on the left, and I'm doing the inverse operation. So the opposite of subtracting is adding, and whatever I do to the left, I do to the right. That gets these to zero out, which is what I want. Okay. Here, I have to know my integers, or I need to be okay using a calculator. This says start at -10 and go up 3. That would take me to -7. I am adding, but when I add a positive and a negative, the result is subtraction. If you plug it in, it does work. It says -7 and -3 is -10. So it does check out. Looking at this one is probably the most missed concept. Here, the opposite of adding is subtracting. So I am subtracting 3 from a -10. So I am starting at -10 and I'm going down 3 more. Okay. The other way to think of it as is subtraction is the same thing as adding a negative. So a lot of kids will think of this as just being adding a negative. Okay. Subtraction is adding a negative. They are the same thing. Those zero out, that gets us our x by itself, which is our goal. And this would give us -13. Okay, when you plug it in to see if it works, it will. -13 plus 3 gives us -10, which checks out. That's what we're looking for. This is my answer. That's my check. On the multiplying problems, we get issues as well. So this right here is a negative coefficient, and I need to get rid of multiplying. That's what a coefficient is, means multiply by dividing. And I need that negative to stay with the number. Here I'm switching the subtraction to addition. Here, the opposite operation is division. I have to keep that a negative in order for that to get a 1. I need that coefficient to create 1 right there. And whatever I do to the left, I have to do to the right. But the trick is knowing that in order to form my 1 here, maybe I need to make the 1 in green so you can see it a little bit better. Okay, I need to keep the number the same. I am flipping the operation of the multiplying to the dividing. And this would get us -5. To prove it works, -6 times -5 is 30. It checks out. Last one, the opposite of dividing is multiplying. So I need to multiply by -6. Those would, opposite operation, cancel each other out there. And I would get x is equal to negative times negative is positive 72. Okay. Checking it, this would be 72 divided by -6 is -12. It does check. Okay. The last thing I want to go over is that most kids do the best when the x is on the left. So rewrite your problem with x on the left. Just flip this thing to the other side. Okay, and then solve the problem like that. So again, this is one of these problems that is probably the most missed here, is starting at -9 and going down 4 more, which takes us to -13. Last one that we're going to go over in this, again, I like my x on the left, so I would want to think of 6x equals -3. And the opposite of multiplying, that's what the operation is dividing. And kids will often tell me the answer is 2 here. But if we do -3 divided by 6 on a calculator, it's going to say it is -1/2 or -0.5. We have 3 and we're dividing it 6 ways. That would get me 1/2, and a negative divided by a positive is a negative. So to review, we are flipping the operation, okay? We're not flipping the sign. And if you get an x on the left, flip it around so that or if you get an x on the right, flip it around. I always like x on the left. Kids do the best when x is on the left. So start your problem with it on the left by putting the number here, the whole number here, over to there.